Hi, this is Mrs. Wiederholt, and I want to welcome you to my lesson video on laws of exponents. Before we get started, I want to preface this video by letting you know that this video only teaches you how to use the laws of exponents when it comes to working with terms that do have exponents. This video does not answer all of the questions as to why we multiply exponents, or why do we add exponents and subtract the exponents. With that being said, let's get started. First, we are going to look at adding terms with exponents. The key thing to remember when adding terms with exponents is that the variables and the exponents must be the same. If they are not the same, for example, here's a variable and an exponent, variable and an exponent. If they are not the same, then you cannot add them. You cannot add or subtract them. However, if the variable and the exponent are the same, then all you do is simply combine, meaning you add or subtract the coefficients. So if we look at our two examples at the right, the first one is 4x to the fifth power plus 6x to the fifth power. And if you notice, the exponent and the variable, they're both x to the fifth power. So that means I can add the coefficients. Now remember, the coefficient is the number in front of your variable. So we know that 4 plus 6 is 10. So that's going to be the coefficient to my answer. And when we're adding or subtracting, we do not change the variable or the exponent. So the answer is 10x to the fifth power. Now if we look at our second example, we see that our variables are the same, but our exponents are not the same. So that means we cannot combine these terms, and so the simplified version or the answer would simply be 4x to the fifth plus 6x to the fourth. We cannot simplify it any further than that because they are unlike terms. Now let's go on to multiplying terms that have exponents. When multiplying terms that have exponents, the only thing that has to be the same are the variables. So if you look at this example, my variable is b and my other variable is also b. So if your variables are the same, you add the exponents. And so that would be, well, b to the third times b to the eighth would be b to the 3 plus 8 power, which would be b to the 11th power. Now remember, when I say b to the third power, that's the same thing as saying b times b times b. And if you're multiplying that times b to the 8th power, that's b times 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 b. So how many b's am I multiplying together? All total, there are 11 b's, and that's why you can simply, a shortcut is just to add the exponents. Now, if there are coefficients in front of the variables, all you do is multiply those coefficients, and then you would continue to add the exponents, just like we did in the example above. So what I have is 8 times 3, which is 24, and then b to the third times b to the 8th is b to the 11th. So my answer would be 24b to the 11th. Now let's look at dividing terms. When dividing terms, we have to remember that the variables must be the same. If the variables are the same, then we simply subtract the exponents. So let's look at our example. We have a to the 15th power divided by a to the third power. Now both of our variables are the same. They're both a's. So that means all we have to do is subtract the exponents. So that will look like this. A to the 15 minus 3 power, and that will equal a to the 12th power. Now, if you have coefficients that you're dividing, you simply divide the coefficients and subtract the exponents. So if we look at our example, we have coefficients of 15 and 3. So we're going to divide those. 15 divided by 3 is 5. Now I'm simply going to subtract the exponents because my two variables are the same. And again, a to the 15th divided by a to the 3rd would be a to the 12th power. And y'all, I need to apologize for how messy my handwriting looks on all of these. That's why I do a lot of typing, because it is hard to write neatly on these videos. But anyway, let's go on to power to a power. Here you will simply multiply the exponent that is inside or within the parentheses to the exponent that is outside the parentheses. So that will look like this. We have x to the 4 times 3 power, which would be x to the 12th power. Now, what if the term inside of the parentheses is a binomial? Well, if you have a binomial squared, first you will expand that squared binomial. And then after that, you will simply use the FOIL method to multiply the terms. So we have 2x times 2x, which is 4x squared. And then our outer terms would equal negative 6x. Our inner terms are negative 6x. So that would be minus 12x. And then our last terms would equal positive 9. So we'll write plus 9. Now let's look at our last example of raising a power to another power. Now actually this is split into two examples. The first one I want us to look at is this one. What if your coefficient is inside the parentheses with the rest of your term, with the variable and another exponent? Well, what you will do here is you will raise the coefficient to the outside power and the variable to the outside power. So that would look like this. 2 to the 3rd power, and then we would have times x to the 4 times 3 power, which is to the 12th power. Now, we know that 2 to the 3rd power is 8, so you could simplify this to 8x to the 12th power. Now, when we look at this term that is raised to the 3rd power, notice that the coefficient is outside the parentheses. If your coefficient is outside the parentheses, you will not raise it to the power that's outside the parentheses. So in this case, the 2 stays the same. It will not be raised to a power. So it's only the term, the variable that's inside the parentheses, that would be raised to the 3rd power. So x to the 4th raised to the 3rd is x to the 4 times 3 power, which is x to the 12th power. So the main thing I want you to see here is, do you see how these two answers are different? And they're different because of the coefficient. If the coefficient is inside the parentheses, you raise it to the power that's outside the parentheses. However, if the coefficient is on the outside of the parentheses, you do not raise it to the power that's outside the parentheses. Now let's look at the outside terms. Now if we look at our example, the term that's on the outside, which is the 6, should be multiplied or distributed to each term that is inside or within the parentheses. Now this is something you have done in Algebra 1 and in Algebra 2 already. So let's go ahead and do this example. We have 6 times 4x, which is 24x. And then I will multiply the 6 to the negative 9, which would be negative 54. And there's your answer. Now, what if our outside term also contains a variable with an exponent, like we have right here? Well, we're going to do the same thing. We still have to multiply the outside term to each term that is within the parentheses, but we will use our exponent laws to help us know how to multiply the variables and the exponents. So let's get started on this one. We have 6x to the 3rd power times 4xy. So I'm going to multiply the coefficients. 6 times 4 is 24. Now, in order to multiply variables that have exponents, the variables have to be the same. So I can multiply the x to the third power times the x. And remember, x has an invisible exponent of 1. So when we multiply exponents, when we multiply terms that have exponents, we actually add the exponents. So this will be x to the fourth power, x to the 3 plus 1 power. Now, there is no other y term, or there is no y term on the outside, so it simply gets carried along. Now we're ready to multiply the outside term to the second term that's within the parentheses. First, I will multiply the coefficients. 6 times negative 9 is negative 54, so I write minus 54. Now, my two variables are not the same, so I cannot multiply them together or add their exponents. So they just each get carried along. That will be x to the third power and y to the second power. So this would be your answer, 24 x to the fourth times y minus 54 x to the third y squared. Now let's look at terms with negative exponents. Now in our first example, we have x to the negative 4 power. Now this one might seem a little tricky, but just bear with me. First, we're going to create a fraction by taking the variable with the negative exponent, and we're going to place it in the denominator. So that's going to look like this. I'm going to create a fraction, and I'm going to place the x to the negative 4 in the denominator. But when I do this, I'm going to change that negative 4 to a positive 4. So it should look like that. Now you're going to say, what about the numerator? There's nothing in the numerator. We place a 1 in the numerator if there's nothing already there. Now let's look at an example where the negative exponent is in the denominator of a fraction. Now it's very similar to what we just did, except this time, instead of creating a fraction that has x to the negative 4 or x to the fourth in the denominator, we're just going to take this x to the negative 4 and move it to the numerator. And when we do that, it will become, again, we'll change the negative 4 to a positive 4. So it's going to look like this. Now, what is remaining in the denominator? An invisible 1. And we usually don't show that, so your answer would be x to the fourth. What if you have a coefficient with your negative exponent? Well, what we're going to do is, if that coefficient is not inside of parentheses, as this example, you have 3 times x to the negative 4. If that's the case, you do not move the coefficient. It stays where it is. So the only thing here that we would move is we would move that x to the negative 4. Well, because this is a whole number, we have to create that fraction. And so it's going to look like this. The 3 is going to stay in the numerator, and we draw a fraction bar, and then we have x to the fourth power in the denominator. Because remember, when we move that from the numerator to the denominator, we have to change the sign. So what if we have a coefficient with our negative exponent in the denominator? The same thing is going to be true as we just did. Because that 3 is not in a parentheses with the x to the negative 4, it will remain in the denominator. And the only thing that we will move up to the numerator is the x to the negative 4. So that's going to look like this. In your numerator, we will now have x to the fourth power, and in our denominator, the 3 will remain. So that is what this will look like, x to the fourth divided by 3. Now, I tell you what, I'm a little tired. This has been a long video, so let's end this video quickly with something that is fairly easy, and that is when your term is raised to the power of 0. Here we go. Any number or variable that is raised to the 0 power will always equal 1. So, if we have d to the 0 power, that equals 1. We could have a to the 5th, b to the 4th, c to the 3rd, d squared times e. If all of that is raised to the 0 power, it will equal 1. Now, I hope this video has helped you learn how to use the laws of exponents, and I look forward to working with you again. Bye-bye.